Hello 7th graders and welcome to lesson 6.2 on solving equations. Now before we get to the actual chapter, there's some really important vocab for us to know first. Inverse operations are operations that undo each other. Addition and subtraction are inverse operations, and multiplication and division are inverse operations. What that means is when I have an equation, say x plus 3 equals 5, to solve for x, I need to get x by itself. So to undo addition, I need to subtract 3 from both sides. And x would equal 5 minus 3, or 2. All right, so the goal when we're solving equations is to get the variable by itself. To do that, we're also going to use the order of operations backwards. That comes into play when we have multiple steps. So if I had both multiplication and subtraction in an equation, we would need to undo the subtraction first. So we know order of operations as PEMDAS. We need to undo addition and subtraction first and multiplication and division next. So to solve this equation, we would add 1 to both sides. Cancels out, then I have 2x equals 4 plus 1 is 5. To undo multiplication, we divide, and x would equal 5 halves. Another super important thing about solving equations is to balance the equation. What I do to one side, I have to do to the other side. So notice I have a plus 1 on both sides. I have a divide by 2 on both sides. We have to balance the equation. All right, so let's get to some textbook examples. Example 1, x plus 3.2 equals negative 8.5. So notice there's decimals and there's a negative number. To undo the addition, we need to use subtraction because addition and subtraction are inverse operations. So notice how they subtract 3.2 from both sides. Another important thing is to balance the equation. And when you subtract 3.2 from negative 8.5, it's going to go further negative, further away from 0. So this is actually like negative 8.5 plus negative 3.2, which is going to be negative 11.7. All right, next example, we have negative 2/3 plus y equals 8. This negative, we're going to treat like a subtraction sign. So to undo subtraction, I need to add 2/3 to both sides. To undo a negative 2/3, I need to have a positive 2/3. Notice how that's done to both sides. So when I add 2/3 to the left, those terms are going to cancel out. I have the y term by itself. 8 plus 2/3 is 8 and 2/3. Next example, I have 30 equals negative 0.5a, or negative half of a. To undo that multiplication, because 0.5a is really 0.5 times a, I need to use division. So we're going to divide both sides by negative 0.5. This is one you could enter in your calculator, or I know 0.5 equals 1/2, and I know when I divide 30 by 1/2, it's the same thing as multiplying 30 times 2. So when we divide by 1/2, it's the same thing as multiplying by 2, which I know is 60, and because that was negative, we have negative 60 equals a. It doesn't matter which order you write the variable and the number in. Sometimes it's easier to see this as a equals negative 60, but if you keep it the first way, that's fine. Okay, last example, q over 3.5, it's a negative q over 3.5 equals 9.2. We are going to make this 3.5 negative and kind of ignore the one there because we can't have a negative variable when we have it equal to a number. The variable has to be by itself. That includes no negatives. Okay, so to undo division, we need to multiply. So I'm going to multiply both sides by negative 3.5. You can see that done here. And 9.2 times negative 3.5. You could enter this one in a calculator, or you could do it by hand. 9.2 times negative 3.5. and we get negative 32.2. All right, so I want you to try to solve these these three at the bottom all by yourself. Pause the video, play it back to see if you got them right. All right, and there are our solutions. Number 1, we subtract 4.9 from both sides. Negative minus a number goes further from 0, more negative. You might have thought of that as negative 9 plus negative 4.9. I know I did. Number 2, we add 17.1 to both sides. When we add 17.1 to this side, we have negative 4.8 plus 17.1. That's a lot easier to think of as 17.1 minus 4.8. So notice I solved that subtraction problem there. R equals 12.3. And number 3, we divide by a negative, so the answer is also negative. We get C equals negative 12. All right, let's do a real-world example. A scuba diver is exploring at an elevation of negative 12.2 meters. As the diver rises to the surface, she plans to stop and rest briefly at a reef that has an elevation of negative 4 55/100 meters. Find the vertical distance that the diver will travel. Well, they already drew a nice little picture for us. So she's starting at negative 12.2 meters. She's going to move up to negative 4.5 meters. We want to find the difference between negative 12.2 and negative 4.5. So we're going to set up an equation. Notice step 1 here. She starts at negative 12.2. We want to know what the difference is, how many we add, or what the in-between is to get to negative 4.55. Now we're going to solve the equation because this looks just like the ones we did on the last page. So remember, to get rid of a negative, I have to add 12.2 to both sides. You have to add to both sides, balance the equation. And then it cancels out on the left. X is now by itself. Negative 4.55 plus 12.2. It might be helpful to add a 0 here, just to be a placeholder. Also, just like on the last page, I think it was example 2, when I have a smaller negative and a bigger positive, sometimes it helps to flip those around and do 12.2 minus 4.55. And you'll get the same answer, 7.65. So the diver will travel a vertical distance of 7/65 meters, or 7.65 meters. All right, let's reflect on this a little bit. How do we know that the diver is moving in a positive or negative direction? Well, if we look at our picture, both of those numbers are negative. I know 0's up here. That means the positives are way up here. So the diver is moving up, the diver is moving towards the positives. So the diver is moving in a positive direction. Okay, I want you to pause the video, try number 5 on your own, and then play it back to see if you got it right. All right, I'm gonna go ahead and solve it. An airplane descends 1.5 miles to an elevation of 5.25 miles. Find the elevation of the plane before its descent. Okay, so here's our plane. It's gonna descend 1.5 miles to be at 5.25 miles. I want to know where it started. So we're going to say x minus 1.5, it descends, so that's a minus or a negative, equals 5.25. All right, to get x by itself, I need to get rid of the 1.5. It's subtracting, so inverse operations, I need to add 1.5 to both sides. And x equals 6.75. So the plane started at 6 miles and 75/100 of a mile before its descent. All right, one more example. Between the hours of 10 p.m. and 6 a.m., the temperature decreases an average of 3/4 of a degree per hour. How many minutes will it take for the temperature to decrease by 5 degrees Fahrenheit? Well, we don't really need to know the time here because it's asking how many minutes. and it decreases an average of 3/4 of a degree per hour. So at the end, we will need to convert hours to minutes, but for now, we're just going to focus on the hour. So we know it decreases -3/4 of a degree. We want to know how long until it's decreased by 5. So we're going to set up a multiplication sentence. -3/4 times x equals -5. To solve for x, to get x by itself, we need to divide by 3/4. Remember, when we divide by 3/4, it's the same thing as multiplying by the reciprocal. So really, what they did here is they divided by -3/4, which happens to be the same thing as multiplying by -4/3. Okay, so they multiply by the reciprocal, and then -5 is just like -5/1. So then I have a fraction I can multiply straight across. A negative times a negative is a positive. 4 times 5 is 20. 3 times 1 is 3. So x would be 20/3. Now remember, this was in hours. So now we need to convert hours to minutes. I know there are 60 minutes in an hour, so I'm going to multiply our fraction by 60, and we get 400 minutes. Or 20 times 60 is 1200 divided by 3 is 400 minutes. All right, just for some extra practice, let's do numbers 1 and 2 of your guided practice together. This is extra, so this does not have to be included in your notes, but we can just use some extra practice. New concept, new practice. Okay, number 1, how many degrees warmer is the average temperature in November than in January? Okay, so January is at -13.4. And I want to know how many degrees warmer it is to get to the November temperature of -1.7. So we're going to say x plus -13.4 equals -1.7. Or we can write this as x minus 13.4 equals -1.7. All right, now we solve the equation, show our work. So to get x by itself, we need to add 13.4 to both sides. And again, when I have a smaller negative plus a bigger positive, I actually find it easier to do a subtraction problem. So I'm going to do 13.4 minus 1.7. And I get 11.7. The average temperature in November is 11.7 degrees warmer. All right, number 2, suppose that during one period of extreme cold, the average daily temperature decreased 1.5 degrees Fahrenheit each day. How many days did it take for the temperature to decrease by 9 degrees? Okay, so this is kind of like our last example on the page before, where it was decreasing 3/4 of a temperature, and we wanted to know how long until it got to 5 degrees. So we're going to multiply how much it decreases each day by x. So 1.5 times x. We want to know how many days it's going to take to decrease by 9. Actually, both of these should be negative because they're decreasing. All right, so now we solve the equation. We're going to divide both sides by -1.5. And negative divided by a negative is a positive. This is 9 divided by 1.5 is also 3/2, which is the same as 9 times 2/3. 2/3 of 9 is 6, so it took 6 days for the temperature to decrease by 9 degrees Fahrenheit. All right, and that's it for notes today, so make sure you took notes either on the PDF provided in Canvas or in your notebook, because you will be submitting your notes for your assignment today.